Hey class, it's Bill Berry with our Week 4 demo. We are moving into the world of object-oriented programming in a tangible way this week. We have used objects in the past, but we have not created our own objects, and that's all about to change right now. So for this week's demo, let's take a look at what we're going to do. We are going to consider that we are working, let's do a business example this week. The book has some more geometric ones, but that's fine, and so does our class examples, but let's take a slightly businessy example just because I think it's easy to understand. We want to create a class for a pizza. And so Pete's Pizza has different types of pizzas, sizes, etc. They offer 3 types of pizzas. We'll keep it simple for the moment: cheese, pepperoni, and veggie. And they usually make their famous hand-tossed crust, which is served on most of their pizzas, but they do have a thin crust option. They do have certain, all these sizes: small, medium, large, and extra large pizzas, and here's the diameters because we're going to need those later. And the customer may include some special instructions on this particular pizza, like no bell peppers, extra pepperoni, extra cheese, whatever. They might have a special request, and if so, that's going to be included. So the first thing we need to do when you're working with classes is you've got to first define all the classes, and we're given a kind of simple one here. We don't have to look and see. We're only dealing with a pizza, not an order, not a customer, not a store, not a chain, whatever. We don't have very far to look in terms of the class. We're kind of hand-fed the class at this early stage. The next thing we have to do is figure out what's going to be in that class. You want to spend, as always, some time in the design phase thinking about this, and we have some classic types of diagrams that we can use to do this, and the one we're going to look at is called the UML Class Diagram. You can read the slides if you like, but let's just zoom through these and then we'll get on to constructing it. But basically you're going to make a box. I use Microsoft Word to do this, but you can make it, there's obviously nicer tools out there in the universe. There's Microsoft Visio. You can use a lot of different tools. Could be fancy, could be not. But at the top of this thing, you basically put the name of the class. And then you put an underscore and a big underline across the box, representing a, sort of a section break to the next thing. The next thing that you do is that you put the data that you're going to maintain. Now, for most classes, you want to have private data, not public data. One of the whole good things about classes and about objects is they maintain their own data and they protect that data from meddling from the outside world. One of the problems with procedural programming is if you make a mistake in some data, you find that, let's say, a list or an array has somebody's messed with it, you've got to go look through the program to see who had access to it, where it might have gotten changed, and you kind of got to go follow that trail to figure out how it got messed up. Well, in a class, things are encapsulated, things are protected, and they're all in this nice bubble that are protected from the outside world. So very often we don't want the outside world to have any access to our data at all. So therefore you see at the beginning of all these guys there's a minus. The minus means the thing is private. I get to mess with it within my own code, but any code that uses my object, that creates objects based on my class, cannot get to that data directly. It only can go through the methods I provide, and this is typical with object-oriented programming. So we give the names of these data, the data that we're going to have. Notice this is all private data. And then we say what type of thing it's going to be. So we have thin crust, that's a Boolean option. There's special instructions, that's a string. And just for fun, even though the book doesn't really cover it till like way back in an appendix, page 1119 if you're interested, we're going to create some enumerated types just because they make this very convenient. So you basically in that top section are telling all the kinds of data that you're going to have, and you're going to give certain properties of it so you get a good mental picture of it. Then the next section has to do with all of the behaviors. So here we're describing all of the methods that we're going to have. Now there are certain classes of these that are very typical. First, there's a class of constructors. And constructors are the ways that you're going to initialize and create an object. So it's very typical to have a constructor. Notice it's just called pizza. And you're going to have a constructor. In this case, I've made 3 just because I want us to get practice. Notice this first constructor, you don't provide any parameters at all. You just say, I want to make a new pizza. The second constructor, you are going to say, I want to say the type and the size, and I'm going to leave the other stuff out. And the third constructor, you're giving a fairly specific, you're going to list everything that you care about for the pizza. So you may have one or more, you always have one, but you may have more constructors. And as we talked about in last week's demos, you can overload the constructor and have different kinds of constructors with different numbers and types of parameters. So that's cool. Now, that's one class. Second class is you're going to have some methods, you may have some methods that let you manipulate that data. Well, why would you have that if we said we want the data to be private? Well, what you're doing with those is you're allowing the user of the programs that are going to use the object to set these things, but you have control because you're watching it through your own methods. So you can make sure that anything that needs to be updated or maintained or changed is all taken care of very carefully. So you're not going to necessarily give them access to all your data, but you're going to give them access to the data that they need to set to make the object work. So in this case, if you decide you want to construct a fairly empty kind of pizza, and then you decide you want to change the type or the size or the thin crust option or set the special instructions, that would make sense to give them access to that. These are called mutators, mutating methods or set methods, because they let you change some data that you're maintaining. The next class is the gets, and those are called accessors. And the accessors also typically are called get functions, and they just return that data. So if you want to see what's in that internal data, again, not all data is going to be visible to the outside world maybe, but in this case it's typical. We want to be able to get the type, size, whether they want thin crust. Now we've also added one other one just for fun as an example, and that is maybe we want to know the area of the pizza. It could be good to know, for instance, when you're selling at the register, hey, this is only $2 more and you get twice the pizza or whatever. So that would be kind of a fun thing to have, and it's a good practice for us. And then last but not least, we have a toString method. Remember that we've seen a lot of times that Java will coerce data into string format. For instance, we concatenated a string and an integer, and it says, oh yeah, I'll take that integer and make it into a string, and I'll smush it together to concatenate. So it is very typical to do that for various purposes, to have a toString method, and that toString method will try its best to kind of summarize things. In this case, we can sort of summarize what the pizza is going to have in it. So that says a lot, and these object diagrams UML class diagrams are extremely important. You can look this up. There's a UML standards. There's plenty of examples. There's a book on this that I have that if you want to know more about UML, that's the Unified Modeling Language. It's really cool, and having a great set of these UML class diagrams actually tells you a lot. You can do a lot of coding right off this diagram, and that's really important. So that's what we're going to do. Basically, we're going to start with that, and we're going to go create the class, and then in the long run we're also going to write a unit test for the class, because we're sort of moving into the realm of client-supplier programming. We are creating an object, a class rather, that is going to be used by another system. So we are the supplier of this class, and we need to make sure that our work is in order, right? We need to make sure that our stuff is as tested and ready to go as possible, and the only way we're going to do that is to instantiate the objects and test them and play with them and use all of our methods and try all of our constructors, etc. So it's really important to think of this together. When you write the class, you write the test for the class. When you write a function, you write the test for a function. You just want to always think about that. And by the way, your assignments require you to do this, so that's another good reason to do it. So I think I'm going to stop this video here, because we've talked through what sort of the thought process is that we need to put into what's going to go into the class, and then we're going to jump into coding the class, but this is a good breaking point. So there you go. Thanks for watching this video. Continue on with the next one so we put this into action in code.